Swayam Prabha. Digital India. Educated India.
Hello everyone. Now our present topic is the spinning geometry. So, in ring spinning, the spinning geometry plays an extremely important role in controlling the yarn characteristics, yarn structural parameter, yarn properties and yarn breakage. So, these are controlled by spinning geometry. So, let us try to understand the implication of spinning geometry and how we can control the spinning geometry. So, spinning geometry, if we see, it is basically the angles and dimensions making up the spinning geometry, all the different angles and their dimensions. So, at every point the dimensions and these angles, they will be the part of the spinning geometry. But in our present discussion, we will not discuss the each and every components, we will discuss a few important parts. The three most important parameters in the spinning geometry are the spinning triangle, which affects the yarn characteristics and spinning performance, the spinning length and the spinning angle. So, these three parameters we will discuss here. We will try to understand their implications. Now, if we see the front roller, this is the top front roller and these are the bottom front roller. There are two types of spinning triangles explained here. One is short spinning triangle, another is long spinning triangle. This is a long spinning triangle and the bottom rollers are here. So, when the material is coming out from the fiber strand is coming out from the front roller nip, the untwisted portion twist does not flow up to the nip point because of this width available. So, twist stops somewhere little bit away from the nip point and this forms a triangle and this is called spinning triangle. And this is due to the change of path of the fiber. So, at this stage, so when the fiber strands come out from the nip point, there is a certain width, okay, and after that it changes the path to form the twisted yarn. And due to this change in path, there is a loss of fibers, because fibers always try to move at the longitudinal direction and suddenly at the edge fibers will have the tendency to move out of the structure and they form the fly, they move away from the yarn structure. And if we want to reduce the fly, we have to reduce this deflection, angle of deflection. So, angle of deflection can be reduced by increasing the length of the spinning triangle, but when we increase the length of the spinning triangle, there is a more chances of end breakage, because this the spinning triangle zone, the fibers are parallel and twist is not there. So, that is the weakest part. So, ideally the spinning triangle should be as low as possible, but if it is very low, then the chances of fiber goes into the waste as fly becomes more. So, twist must run back to as close as possible to the nip of the front roller. So, spinning triangle there is no twist, and in short triangle the lesser breakage will be there. So, there is no, if we have shorter triangle, so breakage will be less, but the fly generation will be more. Now, with this geometrical representation we can see that outlet width. So, when the material comes out from the front roller nip, the outlet width is W O and spinning width is W S P. So, behind that the nip point the outlet width is there. So, W O, so spinning width is little bit lower than that W, and spinning length L S and L L. L S is the spinning length for short spinning triangle, and L F, so L L is the long spinning triangle. Okay. And here the theta is the twist, theta 1 is the twist angle for short spinning triangle, and theta 2 is the twist angle for the long spinning triangle. So, theta 1 is higher than theta 2. So, turns of twist in a yarn are generated at the traveller zone and moves opposite direction to the yarn movement. So, yarn moves, yarn flows direction, sorry, this is given in the wrong direction, I will make it. So, yarn flow direction will be, this is the yarn flow direction, yarn flow direction, and twist flow direction will be in the opposite direction. Now, here you can see the yarn flows out in this direction from the front roller nip, and twist is generated at the ring traveller zone, and through the lappet it goes towards the nip point. Twist should run back as far as possible towards the nip line. This T is the nip line of the front rollers, but it never reaches as far as the nip, because after leaving the roller the fibers first have to be diverted inward and wrapped around each other. So, that is, there has to be some diversion because of the this width, that is the spinning width WSP is there. So, fibers has to be diverted and then it will be form in the as a part of the yarn, and that is why this twist does not follow up to the nip point. But in the compact spinning, the basic idea is that to reduce the width, if we can reduce this spinning width, then the twist can flow up to the very close to the nip point. twist moves up, okay, yarn flow direction, twist moves up until the angle theta, which is the angle of fiber arrangement in the yarn, that is a twist angle, is equal to the angle beta of the spinning triangle. So, that is the requirement. So, twist angle if we increase, then the beta will also increase and it will go little bit closer to the nip point. So, twist angle, the theta and beta should be equal. There is therefore always a triangular shape where there is no twist. So, that is a spinning triangle at the exit of the roller. So, at the exit point there will always be a triangular formation. Most end breakage originate at this weakest point, because the yarn tension in the balloon can be transmitted almost without obstruction to the drafting system, close to the drafting system. So, the yarn balloon tension is moving towards the spinning triangle. So, that and which is the weakest point, where twist in the spinning triangle is 0. So, that at 0 twist portion, so there will be some breakage. Yarn flow direction with a given outlet width W0, the spinning triangle length L determines the width of spinning width, that is WSP, which is always smaller than W0. Due to the difference between WSP and WO, which is negative difference, the edge fibers leaving the drafting system are not caught by the spinning triangle. So, due to this width, the fibers are coming out. So, fibers will be, edge fibers will come out without entering to the spinning triangle, and therefore, not incorporated in the yarn. So, you can see here that this edge fibers directly come out and goes as fly. So, this distance between this WO, difference between WO and WSP should not be too high. Okay, the edge fibers are there. These fibers are lost by the fly and flap. They are attached to the outside of the yarn already formed, and it's actually it goes as in as a uncontrolled fashion. So, there is no control. So, within this zone between the WSP and WO, that zone, so the loose fibers are coming out. Thus, this fibers increases also hairiness. Yarn movement, the greater the difference between WSP and WO, higher the loss of fiber, greater hairiness and adverse impact on yarn structure. So, yarn structure will show that there will be higher hairiness. So, yarn properties, yarn total luster and all the appearance will be deteriorated. With WSP should therefore be close as possible to WO. On the other hand, the length of spinning triangle depends mainly on the twist. Okay. according to the following correlation. So, that is the there beta 1 equal to theta 2 or beta 2 equal to theta 2. That means, if we increase the twist angle theta 1 or so beta 1 or beta 2 will be increased. So, that means the length LS or LL, the length spinning length will be reduced. Since the twist always rise to a state where tying angle beta at the tying point E is the tying point. So, tying point E and the fiber deposition angle theta is always they are equal. High yarn twist results shorter spinning triangle LS. So, for high yarn twist, this is the direction of yarn flow, but low yarn twist will have longer spinning triangle. The greater length means the increase in spinning triangle, size of the spinning triangle, which results weak point and thus ends down. So, here the ends down will be high with a higher length. To keep the ends down rate at the same level for as high twisted yarn, the yarn manufacturer forced to reduce the yarn tension by lowering the spindle speed. So, if we want to reduce the ends down, so we have to reduce the speed, because the at the lower twist level, the thing is that if we use the high speed for lower twist level, then there will be end breakage, because that high spindle speed, the balloon tension will be high and which will exert higher tension in the spinning zone, but at lower twist if we use, the length of the spinning triangle will be high. So, there will be breakage. So, for lower twist we have to reduce the spindle speed. Now, not only the yarn twist, but also the machine design affects the length of the spinning triangle. So, till now what we have seen, the twist, if we increase the twist, the length of the spinning triangle is reduced, but by machine design we can control the spinning length, that is length of the spinning triangle, without affecting the without changing the twist. So, that means for lower twist we can also reduce the spinning triangle. Let us see the spinning triangle. So, the wrapping angle lambda of the fiber stand at the front roller. Now, we can see here this is the wrapping angle. Wrapping angle, by changing the design, machine design, we can change the wrapping angle. This is the wrapping angle. The wider the wrapping angle lambda, the longer the spinning triangle with all the advantage and disadvantages. So, if we have wider wrapping angle, so here the this twist will not flow, but it has got its own advantages and disadvantages. Now, let us see what are these implications. Now, two additional advantages of the deflection at the front roller are: firstly the extra guidance will be there, we will get the extra guidance. So, it is not directly on the floating on the air. So, there will be extra guidance of the fibers by supporting the fibers without clamping them. So, we are not, it has not been clamped, but extra guidance will be there due to the surface contact of the bottom front roller. Secondly, the reduction of abrupt bending of the edge fibers will be there. So, earlier we have seen when the contact was not there. So, there was abrupt change of the edge fibers were there, which was resulting the floating fibers, that fibers loss was there, hairiness was there. So, here abrupt change is not there. We can see here this was the case where lower angle, this is the lower this lambda, lower contact area. Okay. So, extra guidance was not there. So, it has abruptly changed, but when the contact was increased, okay, that is extra guidance was there. So, there is no abrupt change, the angle changes, the fiber direction change, edge fibers direction changes smoothly. Okay. There is no abrupt changes. Being supported over a small surface area at the front roller from the nip point AB, okay, up to the let off point, let off line LL, this is the LL, the fibers are gathered in the curve form. So, there is a curve form. So, this is in the contact area, where is the, where the fiber guidance area, fibers are not actually abruptly changing due to the friction between the bottom roller and the fiber fringe. Okay. The changes will be in the curved form. Okay. So, it is going up to the LL and the fibers are gathered in curved form at the edge and tied in firmly and regularly. So, there in this way the fibers are not going as a fly or hairs, there will be smooth transition. Okay. That is a positive aspect here. We can see that this is AB and LL, where there is a smooth transition. Fiber loss also reduces here. Now, we can see the stresses on the fiber, that is which actually results the end breakage. Now, let us see both the fibers FC and FE. FC is the fibers at the center, FE is the fiber at the edge, are longer than the spinning triangle. These two fibers are longer than the spinning triangle length. This is the spinning triangle length. So, this is the FC and the distance K or N to E. So, this distance spinning triangle, the distance K or from N to E, K or this distance spinning triangle. So, F C or F E, their distance are longer. So, K E or N E. Fiber at the center F C does not change the direction of movement. So, it goes straight way, okay, during its passage through the spinning triangle, but fibers F E, it changes, it bends to a greater or lesser angle at N. So, angle phi. So, at N it changes, okay, the increasing distance any. So, when it was going in straight, the length travelled, distance travelled was smaller, but here the length will be any, which is more than the straight fiber. Consequently, the tensional force on the yarn causes the elongation of the fiber. So, the force is there, so that fiber, H fiber will get elongated with a high stress will be there. So, if beginning at phi is large, so bend, so it if it is the at the beginning point here, so the bending here if it is large, okay, for short staple short spinning triangle, but here at the beginning suddenly the change will be phi will be smaller. So, for long spinning triangle, long, so short spinning triangle the bending will be larger, the elongation of Fe is very high, that is for short spinning triangle. Now, try to see here. So, that is why the tensional force, okay, Ts that this is this plot is the tension force of the on the fiber, Ts of the fibers during this formation of yarn, the total, these are the fiber alignment, the tensional force at the H fiber is maximum. So, tension at the H fiber, this is maximum, and at the center fiber it is minimum. So, during this formation of the yarn passing mainly into the edge fiber. So, in ZE zone, this is the ZE zone is the zone where the tension is maximum, and ZC zone, central zone, the edge zone tension is maximum, and central zone ZC the tension is minimum. So, there is unequal tension distribution among the fiber within the spinning zone for short spinning triangle, but for long spinning triangle the tension distribution is variation is a little bit low. The Fc and the core remains almost free of elongation, okay, and that makes the structural changes. Therefore, almost the entire tensional force is exerted at the by the balloon on the H fibers, okay. The total, because it is supported by only the H fibers. So, that is why the H fibers, when the tension peaks due to the shock or uneven running from the traveller or balloon acts on the spinning triangle, these few fibers cannot bear the full load. So, only few fibers cannot bear the full load, that is why the breakage starts from the H fibers. So, the break or fiber strand slip apart, causing an end breakage. That is why end breakage normally occurs within the spinning triangle from the outside H fibers to the core fiber. First these fibers will break, H fibers, then the tension will be shifted towards the few core fibers. So, unequal distribution of tension results the breakage, but here in case of longer spinning triangle the force load distribution on fibers are almost uniform. So, owing to the large bending angle phi, the tensile force are distributed very unevenly, high on the edge fibers, okay, that is zone E edge fibers, and much less on the central fiber. The central fiber will have much less. Distribution is much better in zone 1 with a longer triangle. Okay. Zone L, this is the longer triangle, the distribution is better. As a result, it can be stated that the spinning condition are improved by reducing the angle of diversion. So, that if we can reduce the angle of diversion, then spinning condition may be improved. That is done by either by reducing the twist or by reducing the twist by increasing the this length of spinning length. Okay. So, that we can do. A long spinning triangle therefore shows a more uniform distribution of force. Since tension distribution over the entire fiber mass in these conditions are there. So, tensile is distributed entire width. So, fewer end breakages are there. Usually now the spinning roller overhanging. So, that usually the top roller is shifted about 2 to 4 millimeter. So, this we can see the top roller is not exactly at the above the bottom roller, it is shifted in the front side to a small amount 2 to 4 millimeter. This is due to we have this gives somewhat smoother running because of weighting force exerts a stabilizing effect act on the running direction. This is the running direction, this force is actually gives the stabilizing force, stabilizing effect, thus preventing the oscillation. So, this top roller is actually fitted on a clamp on a bracket. So, there will not be much oscillation, the oscillation will be reduced, and furthermore the angle of wrap is reduced, the spinning triangle is made shorter, the overhang must not be too large. However, otherwise the distance from the exit of the opening of the apron. So, if it is too large, the distance from the exit of the apron and the nip point will be high. So, that will also result poor fiber guidance and this will increase the irregularity. So, fiber guidance will be, so there will be optimum overhang. Now, this is the there are two angles of wrap. So, angle of inclination of drafting arrangement. So, this is alpha 1 and alpha 2, and if the angle of inclination is more for higher an angle of inclination. So, that angle of lap will be less. So, alpha 2 is more than alpha 1, in that case alpha 1 will be epsilon 1 will be more than epsilon 2. So, epsilon is the angle of lap, angle of guidance. So, spinning triangle will be here there will be long spinning triangle and in this case short spinning triangle. We can control the spinning triangle by changing the inclination of drafting arrangement. The range of alpha is between 45 to 60 degree. So, typically 45 is very commonly used. So, roller overhanging we have discussed 2 to 4 millimeter, shifted towards to top, the top roller swinging is avoided, smooth running should not be too large, so that as we have discussed, the uncontrolled movement of the fibers will be there. So, larger distance free the distance from the apron nip. So, we will have uncontrolled movement. So, we have actually discussed the impact of the spinning triangle, what are the different implications, how the force distributions are there for long spinning triangle and short spinning triangle, what are their implications on the running performance and quality, and we will stop here. Thank you.